Okay, geometry students, in this video we will be looking at the converse of the Pythagorean theorem. The converse of the Pythagorean theorem. We know that the square of the length of the hypotenuse equals the sum of the squares of the legs. In other words, we know this is true. A squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. We know that. But is the converse of this true? In other words, if you are given three lengths which satisfy the Pythagorean theorem, does that mean we have a right triangle? Okay? Remember before we said, now listen carefully, if we have a right triangle, then L squared plus L squared equals 8 squared. But now I'm turning it around. Now I'm saying if L squared plus L squared equals 8 squared, do we have a right triangle? Okay? Excuse me, sorry. So we're going to take a look at the converse of the Pythagorean theorem, okay? Your heading today is obviously converse of the Pythagorean theorem. Please copy that in your notes, lesson 9.3, and be sure and include today's date, okay? Converse of the Pythagorean theorem, lesson 9.3, and be sure and include today's date. Let's start off by looking at Theorem 9.5 and also a proof of this theorem. Now, when I say proof, relax. I'm not going to make you learn it, and I'm really not going to do the proof. I'm going to tell you where you can find this proof in the book if you want to look at it, okay? But it's pretty much a common sense type of theorem, so we're not going to spend a lot of time on the proof. In fact, we're not going to spend any time on the proof. But let's take a look at Theorem 9.5, converse of the Pythagorean theorem. Listen to it carefully, students. If the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the two shorter sides, then the triangle is a right triangle. Okay, I'm going to pause here a second and be quiet. Go ahead and copy this theorem down. You are responsible for this. If the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the two shorter sides, then the triangle is a right triangle. Please copy this down. Okay, while you're finishing copying this down, let me show you what this is saying, okay? I know a lot of you understand the theorems when you hear them, but also a lot of you need to get a picture of it, so I'm going to show you a picture of this, okay? If I have a triangle in which the sides are 3, 4, and 5, okay? In fact, can I be honest with you? We don't even need the triangle. If I told you the lengths of a triangle, the three sides were 3, 4, and 5, well, listen to me. Please listen. If this is a right triangle, then we know 5 has to be the what? Hypotenuse, because the hypotenuse is always the longest side. Okay, now, I don't know if I have a right triangle, but I'm going to take the longest side and pretend it's the hypotenuse. And I'm going to pretend the two shorter sides are the legs. So all that this theorem is saying is this. Take the two shorter sides. Take notes on this, please, guys. Copy this down. Take the two shorter sides, square them, and add them together, and they should equal the longest side squared. If you have a right triangle, this will be true. Well, let's see. 3 plus 3 is 9. 4 plus 4 is 16. 5 times 5 is 25. 9 plus 16 is 25. 25 equals 25. Check. So I know for sure, students, if I have a triangle that has these three lengths right here, then I know for sure I have a what? A right triangle. That's all that this theorem is saying, okay? Nothing more, nothing less. So if you have a Pythagorean triple, then you have a right triangle. Okay, make sure that makes sense. Alright, let's continue on. Now, I'm not going to look at the proof of this theorem like I mentioned earlier. To me, it really is pretty much common sense. However, if you would like to view the proof of this theorem, you will find it at the bottom of page 441. And I know that all of you are quickly responsible for this proof, okay? But it does explain this theorem. Alright, now, let's take a look at a couple of problems real quick that apply this problem. Alright, I want you to take notes on these. Please copy this in your notes. You're welcome to work ahead of me, but please listen carefully if you do that, and make sure you get the problems correct, okay? Alright, here's the first problem. We have a triangle that has sides of lengths 9, 12, and 15. Now, some of you are already going like this, and you shouldn't be. Just stop and wait. The first thing you want to do is make sure you have a triangle. Maybe you don't. I mean, sure, I just said to you, you have a triangle with these lengths, but let's make sure. Remember, we learned about 2 months ago, we learned that any two sides that you add have to be longer than the third side in a triangle. So find the two smallest sides, add them together, and the sum of these two sides, that better be longer than the third side. Is it? Yes, it is. So we know we have a triangle. If we had not gotten out a number bigger than 15, then we don't even have a triangle. So we're done with the problem. We just stop. Okay. Now that we know that we have a triangle, you take your two smallest sides, which are 9 and 12. We square them and add them together. We take the longest side and put it over here. All right. 9 times 9 is 81. 12 times 12 is 144. Let's add those together, and we should get 225, okay? 15 times 15 is 225, okay? So it checks. So you know now that anytime you have a triangle that has side lengths of 9, 12, and 15, you know automatically it's a right triangle. You know this is a leg, and this is the hypotenuse. It's really pretty simple, students. It really, really is. Okay, alright, let's go ahead and take a look at another problem. You're welcome to work ahead, or you can work with me, whatever, or stay with me, whatever you would like to do. Okay, students, here we go. Now, I would like to first of all suggest to you that you put these in order. Two smallest sides first, and the longest side second. Now, with my calculator, I typed in the square root of 95, and when you type in the square root of 95, you get 9.74. Then hit times 4, because whenever the 4 is right next to a radical, it means multiply. So if you type that in your calculator correctly, you're going to see this is approximately 38.9, okay? So that shows you right there that this is the longest side, okay? So I would write these sides from the shortest to the longest. So 15 comes first, then 36, then 4 square root of 95, okay? Now next, I would very quickly add these two together and make sure they're bigger than this side. Well, if you add these two together, you get 51, and 51 is a lot longer than 38.9. Remember, this is 38.9, okay? So the first thing I do is I add my two smaller sides together to make sure I have a triangle. Now that I know that I have a triangle, let's see if this triangle is a right triangle. So one of my legs is 15, or one of my shorter sides is 15. My other shorter side is 36. And my longest side is 4 square root of 95. Now watch, students, how I do this. We square the whole thing. Now if you watch carefully, I will help you with this, okay? 15 squared, as we learned in the last problem, is 225, okay? 36 squared is 1,296. Now, be very careful. When you square this, you square both parts. So when you square 4, 4 times 4 is 16. Anytime, please learn this shortcut now, students. Anytime you square a square root, you cancel out the square root, thus leaving you with a number on the inside. So if you square a square root, the square cancels out the square root, leaving you with the number on the inside. So when I square the 4, I get 16. When I square the square root of 95, I get 95. What are these two numbers doing to each other? Well, what were they doing up here? Multiplying. So what are they doing here? Multiplying. Okay, let's go over that again. You square the 4, you get 16. Square the square root of 95, you get 95. Multiply these together, and you get 1,520. So let's add these two together, and on the right side, let's see what we get, okay? 225 plus 1296 gives you 1,521. And over here, 1,520. Now they're really close, but they have to be exactly equal. So these three sides here will never be the sides of a right triangle. Okay, you do not have a right triangle. So really, guys, it's pretty simple so far. If I give you sides, you tell me whether or not you have a right triangle. Okay, all right, moving on. The next two theorems are really, really cool, and most students have never even heard of these two mathematical principles. Did you know that there is a way to know whether a triangle is right, acute, or obtuse? Just by knowing the lengths of the three sides. You don't even need to know the measurement of the angles. Okay? It's really neat. Let me show you. Here are the two theorems that will help us. Here's the first theorem. Go ahead and copy this down while I read it. Theorem 9.6. Now it sounds confusing, but I will explain this to you very, very well, and I'll make this very easy to understand. If the square, but copy this down please, if the square of the length of the longest side is less than the sum of the squares of the lengths of the shorter sides, then the triangle is acute. If the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the two shorter sides of a triangle, then that triangle is acute. Okay, please copy that down. I'll give you a couple seconds to do that, and then we're going to move on. Okay, students, here's what I'm saying. Let's say you have three sides, okay? Three sides of a triangle. And write this down, please. You take the two shortest sides, square them, and add them together. If that number is greater than the longest side squared, then you know for sure that you have an acute triangle, just like that. Isn't that neat? Let's go back a page real quick. Let's go up here. Over here, the last problem we did in your notes, remember, we had 1,521 is greater than 1,520. This side is greater. Well, then I know for sure this triangle right here is what type of triangle? Isn't that cool? I know that without knowing any angles at all, okay? So here's Theorem 9.6 in a nutshell. If you square the two shortest sides and add them together, and when you're done adding them, if the number you get over here is greater than the number you get over here after you square this side, it is going to be an acute triangle for sure. Now that's really, really helpful, okay? I'm going to move on in just a second. Please copy that down, then we're going to move on. Okay, Theorem 9.7. You are responsible for this. Please copy this in your notes, okay? If the squares of the length of the longest side of a triangle is greater, up here it was less than, now it's greater than, okay? If the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the two shorter sides, then the triangle is obtuse. If the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the two shorter sides, then the triangle is obtuse. Okay, please copy that down. I'll give you a couple seconds to do it, and then I'm going to summarize all this stuff that we've learned so far. Then we'll look at a couple more problems, and we'll be finished with your notes today. Okay, here's what this is saying. If you square the two shortest sides and add them together, and you get out a number when you're all done doing this that's less than the longest side squared, then you know for sure automatically you have an obtuse triangle. Just like that. Okay? And that's pretty cool. That's what this theorem is saying. You know what I think, guys? I think we need to see this all together on one big page, okay? So here it is. You can copy this down or just watch. It's up to you. If you have a squared plus b squared equals c squared, then you know you have a right triangle. If you have a squared plus b squared is less than c squared, then you know that you have an obtuse triangle. And if you have a squared plus b squared is greater than c squared, then you know that you have an acute triangle. That's it, guys. That's all you have to know. You can memorize that so easily. Okay, so let's apply this to two problems, and then we're finished. Okay, here we go. Let's quickly look at two problems. Here we go. Okay, copy this down. You can work ahead, or you can watch me. I want you to decide whether we have a right triangle, an acute triangle, or an obtuse triangle. Okay, so here we go. First of all, let's make sure we have a triangle. Take your two smallest sides, add them together, and they have to be greater than the third side, and they are. 2 plus 3 is 5, so we know that we have a triangle. Next, let's see if it's acute, obtuse, or right. So take the two smallest sides, add them, square them, and add them, and over here we're going to square the longer side. Well, 2 times 2 is 4, 3 times 3 is 9, 4 plus 9 is 13. 4 times 4 is 16. So, are these two numbers equal? No, they are not. So we do not have a right triangle. Okay, this side over here is less than. Alright, 13 is less than 16. Let's go back a page. Whenever this side here, the sum of your two smaller sides is less than the square of your longest side, you know for sure that you have an obtuse triangle. Okay, so we know that we know the triangle that has these three lengths here is obtuse. Is obtuse. It's that simple, students. Okay, one more and we're done for the video, okay? Sides of lengths 4, 5, and 6. Now again, add your two smallest sides together. You get 9. 9 is greater than 6, so we know for sure we have a triangle. Now, let's see if we have a right triangle, an acute triangle, or an obtuse triangle, okay? So here we go. Take your two smallest sides, square them, and add them together. Then take the longest side and square it over here. Okay, let's see what we get. 4 times 4 is 16. 5 times 5 is 25. 16 plus 25 would be 41. Okay, 16 plus 25 would be 41. 6 times 6 is 36. So now the left side is bigger than the right side. Okay, the sum of the squares of your two smaller sides is greater than the square of your longest side. So let's go back to look at our little chart here. Whenever this left side here is greater than the right side, then we have an acute triangle. So I know this triangle here is an acute triangle. That's pretty cool, guys. You did not even have to know the angles to know this was an obtuse triangle and this is an acute triangle. I hope this video has been a help. I hope it makes sense. Contact me if you have any questions at all.